All right, this is Honors Algebra 2 Pre-Calculus. We're doing Chapter 10 in Pre-Calc, which is conics. So I stole some images from the interwebs because I wasn't going to draw these crazy things, and we all know my drawing skills are terrible. So I printed you this image from the interwebs, and we're going to talk through this and then talk a little bit about a preview of what conics are. So conics are so called because they're shapes that are created by taking this sort of hourglass shape that we have, these two cones stacked atop each other, that are point to point, right? And we take think of it as a piece of paper or a plane or whatever you want to think of it as, but you're cutting through those two cones to make a shape, and the cross section of the area that you cut becomes this shape that we call a conic. So if you were to take a horizontal piece of paper and cut this way, you'd end up with that little white cross section is a circle, right? And I'll show you a better image of this in a second. If you were to take that piece of paper and instead of cutting across directly horizontally, you cut across on sort of an angle, you end up with an ellipse, which is sort of an oval shape, right? So you end up with an ellipse, which we're going to cover in 10.3, right? If you take that slice of paper and you only cut off sort of a corner of the cone, right, you end up with this shape that we call a parabola. And you've seen parabolae before. You saw them in algebra. We know that they are the graph of x squareds, or we're going to learn they're also the graph of a y squared. But the idea is that you've seen this before, just not in this way. And then the last one is a hyperbola, which is what happens if your slice of paper cuts into both cones. So a little bit on the top and the bottom. So I'm going to show you, there are also 4 other kinds of conics that we're not going to address in this chapter. And you can see we'll do ellipses in 10.3 and parabolae in 10.2 and hyperbolae in 10.4. And we're not actually going to do a whole section on circles. We're just going to talk about the equation and how it's useful. And that circle equation is going to come up a lot for you, but we'll walk through how it works a little bit. There are 4 other kinds of conics. So these are the ones we're not going to worry about a whole bunch in this chapter because they're what we call degenerate images. So degenerate conics are conics that give us something that doesn't follow all the other rules of the conics that we're going to go over. So for instance, if you were to take that slice of paper and cut directly through where the points two meet, you would just get a single point. There'd only be one dot, and that dot would be a conic. If you were to take that slice, and so you can cut through a couple different ways. You can cut through horizontally, and basically if you cut through that point where they meet, you get a single point. If you cut your slice of paper along the edge of the two conics, of the two cones rather, you end up with a line. And if you were to cut essentially right down if you cut right down the middle, what ends up happening is you get 2 intersecting lines that make an X. And all of those are called the degenerate conics, and we're not going to go into them in great detail because they don't pertain really to what we're going to cover. But so this is my slightly better image that I printed, again, stolen from the interwebs. Because at the bottom of this image, you'll see that they actually show you what the graph would kind of look like. So we know a parabola looks like this U shape, right? Hyperbola kind of looks like 2 parabolae, but it's not, but that's kind of what it looks like. I think we're all familiar with a circle, and an ellipse is what you maybe have called an oval, but its mathematical term is actually an ellipse. So we're going to spend chapter 10 working through these shapes, talking about ways to graph them, and different uses for them, and that's kind of the gist.